All right, guys, so let's have a look. Hypothesis testing is one of the topics that everybody hates. So let's have a look on how we can do it. And I'm going to try to explain this in the simplest way possible so that everybody can understand what are the different cases that we need to be paying attention to and we need to be aware of. So let's have a look at this question here. It says a single observation is taken from a binomial distribution where n is 6 and p is p. The observation is used to test the null hypothesis being p is equal to 0.35 against the alternative hypothesis where p is greater than 0.35. So this is what we call one-tailed test. This is because we have the alternative hypothesis that is greater than or less than. If it was two-tailed test, then it would have been equal to zero, not equal to zero, sorry. And if that was the case, then we had to test both sides of the both end of the spectrum. So what do I mean by that in this case here? So in a normal, I'm gonna draw a bell-shaped graph. Usually this is used for the normal distribution, but we can also use it here. So if it's one-tailed test, we only check for the extreme values only on one side, either the top end side or the bottom end side. In this case here, is that going to be either the top or the bottom? But in this case, because given that the probability is greater than 0.35, we check from the top part of it. So that's the part that we're going to be focusing on and finding what is my critical value, where my critical region starts. So in this case, I need to find what is the border of where this critical region starts. Because let's think about it. The alternative hypothesis is what we are testing for. We believe the null hypothesis is correct. We believe that the p is equal to 0.35. But if someone comes and try to throw an assumption that says, okay, I actually believe p is greater than 0.35. If that's the case, then we need to test that. We need to verify if that is correct or not by measuring for our extreme values. So as I said, you always assume, so in this case, this is one-tailed test, and therefore we do not have to test for the bottom part in this case here. We're only trying to find the critical value, which is for where the region starts from where we say that actually, you know what, if it falls in that extreme value, yes, I do believe that your alternative hypothesis is p is greater than 0.35. But before then, what we do is we assume h naught is true. So if h naught is true, then what does that mean? X is binomially distributed where n is 6 and p is 0.35. So in order to find the critical region, we need to find what? It says using the 5% significant level. So this part here represents the 5%. Okay? So we need to find the probability of a value being 5% or less than the 5%. Okay? So if it's not less than the 5%, then that means that value is turning out to be on the other side here, which is not what we want. Okay? So in this case here, the way that we find the critical value is a bit of a test and trial with a couple of the values. So in this case, we can check for probability that x is greater than or equal to 4. So we are saying that this value here is 4. And how do you calculate the probability when x is greater than or equal to 4? We have to simply do 1 minus the probability that x is less than or equal to 3. So if you do this, and what does that give us? That gives us 1 minus 0.8826, and that leaves us with 0.1174. So 0.1174, is this correct? 0.1174, that represents 11.74%. That is in this case incorrect. So therefore we need to try by increasing the value a bit more. Let's say that x equal to 4 is turned out to be 4 is equal to here. This is where 4 is. So that's not the value that we want. We want the value that falls under that 5% or less than that 5%, top 5%. So in this case, let's try to increase the value. So therefore, we use x is greater than or equal to 5. If we do that, then that gives us 1 minus probability that x is less than or equal to 4. And therefore, this is 1 minus, if you put this in a calculator, using the calculator, that gives us a value of 0.9777. and therefore that simplifies down to 0.023223. And we can see that this value at least falls under the 5% significant level. So therefore, our critical value, critical value is equal to 5. That's where the region starts. But our critical value is 5, so therefore the critical region is either going to be critical region is greater than or equal to 5. So it can be 5 or 6 in this case, because 6 is the top number that it can be. And that is it. That is simply the answer for this part here. And in order to calculate part B is telling us to calculate the actual significant level, because the 5% is not the true significant level in this case here. The actual significant level is the probability where the critical region start from. So the actual significant level is equal to 2.23%, which is the value that we calculated for when you calculating the critical value. So that probability that we get when you calculated critical value will be our actual significant level. Essentially, we are trying to say that that's where our region starts from. Okay, so this is here how you answer and how you calculate your critical region when it's one tail test.